Okay, question 15 gives you a diagram of y equals f of x, and what you have to do is they tell you it's f of x is k times x take a times x take b to the power of a half, and there's the diagram they give you there. Okay, and then it says find the values of a, b and k for question A. Maybe you can just see that. First thing we have to look at is the roots of 4, x equals 4 there, and x equals minus 5, but that has a turning point there of minus 5 there, and that has a bearing on the equation. So let's go to the maths. So the roots are at x equals 4 and x equals minus 5, so the factors of the original equation have to be x take 4 and x plus 5. But because that's a turning point, the x plus 5 is the term that's squared. So f of x is k times x take 4 times x plus 5 squared. Now it goes through 1, 9. That means that when x is 1, y is 9. So y is 9, is it? So we'll put 9 there. It's k times, and we'll replace x with 4. Remember, y equals f of x, so you can replace that with y if you wish. Okay, so 9 is k times 1 take 4 times 1 add 5 squared. 1 take 4, of course, is negative 3. 1 add 5 is 6. 6 squared is 36. Minus 3 times 36. I'm sure you don't need a sum there, but there it is over there. 336 is 108. So minus 3 times 36 is minus 108. So k is 9 over minus 108. 9 12s are 108. So it's 1 over 12. So k is negative 112. So a is 4, b is minus 5, and k is negative 12. Now for part B, it starts telling you here, for the function g of x, which is f of x, take away d, where d is positive, determine the range of values for d for which g of x has exactly one real root. Okay, well, no expense spared here whatsoever. There is a tracing of the original function. Now, if you got f of x take away d, that means you're lowering it. So there's f of x, maybe take 1, take 2, take 3, take 4, take 5, take 6, take 7, take 8, take 9. There's f of x take 9. So the 1, 9 has gone down to 1, 0. So, and that has actually got 2 roots. Okay, up here it's got 3, but when you go down to this particular point here, it's got 2, and if you make it bigger than 9, like 10, then you have only one real root. Okay, so if d is bigger than 9, you have one real root, because you're lowering it by more than 9, and that's your answer there. So let's just write down what I wrote there. D has to be greater than 9 for one real root.